It is a warm, clear afternoon in the garden. The sun is out, the air is still, but something is missing. There is no movement between the flowers, only an absolute, heavy silence. We are neurologically wired to prioritize noise and movement. We scan for sudden motion to identify threats, which often causes us to overlook the significance of a sudden lack of activity. But in a garden that usually hums with life, this silence is an early warning signal that the environment is no longer safe for foraging. Hours before a human can spot a cloud or check a weather app, the local atmosphere has already shifted, and the bees have already reacted. To understand the scale of this shift, consider that between 20,000 and 60,000 foraging bees will completely vanish from this landscape in a matter of minutes. This is not a matter of local folklore. It is a documented, colony-wide evacuation that occurs in backyards every storm season. A quiet garden on a sunny afternoon is a massive biological lockdown, a response to a threat that remains invisible to the human eye. The trigger for this lockdown is a drop in barometric pressure, the physical weight of the atmosphere pressing down on the Earth's surface. As a storm system approaches, this invisible weight begins to fall, often 6 to 12 hours before the first clouds or rainfall appear. Human biology cannot register these minute changes in air density, leaving us blind to the initial stages of a weather front. Honeybees, however, navigate using specialized mechanoreceptors that act as biological pressure sensors. These microscopic structures on the antenna physically react to the changing density of the air, allowing the bee to feel the weight of the atmosphere. When a single scout bee detects this pressure drop, she does not retreat alone. She initiates a colony-wide communication protocol. The hive uses pheromones and the waggle dance to rapidly broadcast an evacuation order to every forager currently in the field. This transition occurs in a matter of moments. Foraging activity across the entire superorganism drops in near unison rather than bee by bee. The hive acts as a single, hypersensitive antenna, converting a microscopic drop in pressure into a synchronized mass retreat. Researchers have found that this biological response is more nuanced than a simple reflex, as not every pressure drop triggers an evacuation. Small, gradual changes, the kind that precede a passing cloud, cause no reaction. The colony only initiates a lockdown when the pressure drop is sharp and rapid. This has led to a debate among entomologists. Is this behavior specifically for sensing storms, or is it a general survival response to any sudden instability in the environment? Further research into the hive reveals another layer of complexity. The response depends heavily on the experience of the individual bee. Younger foragers are far less reliable at executing the retreat than older, veteran bees who have spent more time in the field. This suggests that colonies may build an environmental memory over a season, learning to better interpret the signals of the air. The silence of the hive is the result of a constant negotiation between hardwired instinct and lived environmental experience. By the time the storm arrives with visible lightning and heavy clouds, our visual cues trail hours behind the bee's 12-hour warning. Long before these mechanisms were understood, 19th century farmers were already using honeybee activity as a reliable local weather instrument. Historical records, such as this 1731 almanac, specifically instructed readers to listen for the bees as a primary method for predicting severe weather. Rural beekeepers often trusted a suddenly quiet hive over the appearance of the sky, knowing that instinct was often more accurate than visual observation. Modern science now validates this folklore, proving that these early observations were an accurate translation of atmospheric data. For a modern gardener, this behavior remains a hyper-local storm warning system that is often more accurate for a specific backyard than a regional forecast. Observing these shifts provides a real-time indicator of the local atmospheric pressure and the immediate rhythm of the environment. A garden is never just scenery, it is an environment constantly broadcasting information. An eerily quiet afternoon is not an empty void, it is a complex language we are only beginning to read.